So, continuing Lab 8, my discussion on Lab 8, with the conclusion section that I was unable to complete in that previous video for Lab 8. So, for example, how can I distinguish between two colorless liquids? By doing an elemental analysis, and if I find that the percentage of oxygen in that liquid is 88%, it definitely tells me that that colorless liquid is water. And if my percentage of oxygen is 96%, then it's hydrogen peroxide. Okay. So you can identify a substance doing an elemental analysis and applying the law of definite proportion. So, in conclusion, what are some of the applications of law of definite proportions? So the law states that if you have a compound, it always contains the same elements in the exact same proportion no matter where you obtained that sample of the compound. All right. So a good example, as I explained previously, is water, whether it is just a drop of water or an ocean full of water. All right. The chemical composition is not going to change. 88% will always be oxygen, and the 11% will be hydrogen. All right, when you do a percentage mass composition of the drop of water or the ocean full of water. So, what could be some of the real life applications for this law of definite proportions? For example, when you're doing something in the kitchen like baking, all right, baking a chocolate cake, for example, all right, you have the exact proportions of the flour, sugar, eggs, all the ingredients to make the desired cake. If you want to bake one cake, then you will follow that recipe. Suppose you want to make two cakes, then what you'll do is whatever the amounts that the recipe lists, you'll take double the proportions of all the ingredients and you can make two cakes. So in a way, what you're doing is following the law of definite proportions. Okay. What could be some other examples? For example, glucose. Okay, glucose has a molecular formula of C6H12O6. This is a biomolecule that is utilized by the body to produce energy. Okay, so it means that 6 atoms of carbon combined with 12 atoms of hydrogen and 6 atoms of oxygen in one single molecule of glucose. So now if we take the individual masses, you will find that carbon makes up 40% of glucose, hydrogen is 6.7%, and oxygen is 53.285%. Okay. If you had a compound that was 45% carbon and 45% oxygen and 10% hydrogen, then it's not glucose, it's some other compound. All right. So these percentage by mass is always going to be a constant for any sample of glucose. Okay. Purity of a compound can be tested using this percentage mass analysis. All right. Purity of water. Okay. If you have a sample of water, you want to test how pure that water is, then of course 88% by mass of that sample should be oxygen, 11% should be hydrogen. How would this apply in the field of nursing and health? Suppose you have a patient who ingested an unknown compound and you want to make sure what that compound is. Of course, you could do some physical analysis like density, melting and boiling points like we did in the previous lab. But you could also do an elemental analysis and determine the mass percentage of each of the elements in that unknown compound. And that's a good way to identify that compound. All right. Once you have the elemental analysis, that kind of confirms what your compound is, because you can go to the literature values and then compare. Okay. And that concludes this lab.